Alright, we're taking derivatives, and we're going to take the derivative of some log functions, or in this particular case, natural log functions. Okay, let's say that I have y is equal to the natural log of x, and I want to find y prime. So what you're going to do is you're going to take the derivative of what's in parentheses. So we're going to take the derivative of x, and the derivative of x is 1. And then you just rewrite what's in parentheses. And it's that simple. Right, so pretty simple stuff. Let me write, let's say for example we had f of x is equal to the natural log of some function in here. We'll just call it g of x. And we wanted to take the derivative. We want to find f prime of x. So you just write it like this. This is the general form here. So you take the derivative of this, which is g prime of x, over, and then we just rewrite what's in parentheses, which is g of x. So that's your formula that you're going to use. Take the derivative of what's in parentheses and then rewrite it in the denominator. Alright, now let's work some problems. Let's say we have y is equal to the natural log of x squared. Now, you really need to know what the properties of the natural logs are. So the property is that you can take this 2 and bring it out front. Now, this is not the derivative. This is the property. The properties of the natural logs. You can take this exponent and bring it out front. So this is actually equal. These two are equal to each other. Now what we want to do is we want to go ahead and take the derivative. So I'm rewriting this problem here. So now we can take the derivative. So 2 times, now remember what the derivative of the natural log of x is. It was just 1 over x, right? Derivative of x is 1, then we rewrite x. So this is y prime, and of course we can rewrite this as 2 over x. So knowing these properties of the natural logs is going to save you a lot of time. And if you don't know them, well, I'm going to help refresh your memory. Alright, let's look at another one here. Let's say we had y is equal to the natural log of x to the 4th plus 3x squared plus 2x. And we want to find y prime. Well, we take the derivative of everything in the parentheses. So this is 4x cubed plus 6x plus 2. Right? And it's all over what's in parentheses. So that's going to be x to the 4th plus 3x squared plus 2x. Okay, we just rewrite it. Alright, let's look at another one. Let's say that we have, man, it gets on my nerves. Let's say that we have y is equal to the natural log of 1 over x. So what I'm going to do here is I'm going to rewrite this before we take the derivative of this. So this can be rewritten as the natural log of 1 minus the natural log of x. So we're just rewriting this. This is the properties of the natural logs. So the natural log of 1 is 0. Okay, so we can just rewrite this as such. So you need to know the natural log of 1 is 0. Alright, now we can take the derivative of this now. And so we have the derivative of the natural log of x is just 1 over x. So we have negative 1 over x is our derivative. So we need to know how to simplify this thing down before we actually start taking the derivative. It's very important. Alright, let's look at another one, of course. We have y is equal to the natural log, and I'm going to write x minus 1 up here in the numerator and x plus 1 down here in the denominator. So we definitely don't want to just take the derivative of that. So that's going to get nasty. So we're going to break this up, and this is minus the natural log of x plus 1. Now we can take the derivative of it. Right, so if it's written as a fraction, you can break that up and put a minus sign here. So now we can take the derivative of x minus 1, which is 1, over, and then remember we just rewrite what's in parentheses, minus, and then take the derivative of what's in parentheses, which is going to be 1, over x plus 1. And we'll just go ahead and stop right there. So the derivative of y, I've got it written right down here as 1 over x minus 1 minus 1 over x plus 1. So as you can see, breaking this up is going to make your life a whole lot easier. Alright, so we have y is equal to the natural log of x plus 1, and this is going to be raised to the third power. So I'm going to rewrite this. I'm going to take this 3, bring it out front. Now we're not doing the derivative yet. Well, these are just properties of the natural log. Now I can take the derivative. So the derivative of x plus 1 is just 1, and then you just rewrite what's in parentheses. And this will be our y prime. And of course I can rewrite this as 3 over x plus 1. Good enough? Alright, this one here will be a little bit more difficult. We got y is equal to the natural log of x plus 1 raised to the 4th power over x plus 2, and we're going to raise that to the 5th power. Now, can you imagine if you had to take the derivative of that? So what we're going to do is we're going to break this up. So this is the natural log of x plus 1 raised to the 4th minus the natural log of x plus 2 raised to the 5th. And now we can do one more move on this. We can take the 4 and bring it out front. We're not taking the derivative yet. We're just rewriting this thing. We're breaking this thing completely down. The natural log of x plus 2. Okay, so we brought the 5 out front. Now we can take the derivative of this. Makes life a whole lot simpler. So y prime is equal to 4 times the derivative of x plus 1 is 1 over x plus 1 minus 5 times the derivative of x plus 2 is 1 over x plus 2. And of course we can rewrite this one more time. So this is 4 over x plus 1 minus 5 over x plus 2. And we're just going to keep it just like that. Okay, let's do another one here. How about the natural log of x times x plus 1 squared, and that's all over x minus 1 cubed. And I don't know, let's throw a 3 up here also. Woo, how would you like to take the derivative of that stuff inside? That'd be nasty. So we want to expand expand this. That's the word that I need to use, expand. So let's first expand this thing out. So first off, we have this 3 up here. So I'm going to take the 3 and bring it out front. Now we're expanding this. We are not taking the derivative. And I have x times x plus 1 quantity squared. I'm going to go ahead and keep that in the parentheses here, minus the natural log of x minus 1 cubed. Now, this 3 here is actually multiplied by the whole thing. Okay, 3 times this and 3 times this over here, because this whole piece here is in parentheses raised to the 3rd power. Man, this is going to get crazy. Alright, now let's go ahead and expand this. I'm going to go ahead and leave this bracket here. So this becomes the natural log of x. And because this is multiplied, this is going to become a plus. Alright, the natural log of x plus 1 squared. Okay. And then we're going to have the minus still, the natural log of x minus 1 raised to the 3rd power. And I'm going to put a bracket here, because remember this 3, right, is going to be distributed across everything. And I'm going to go ahead and distribute that 3 across. So 3 times the natural log of x. Now you see this 2 here? I can bring the 2 out front. But remember, we're multiplying through by the 3. So this is going to become a plus 6 natural log of x plus 1. That's right, we hadn't taken the derivative yet. And then the 3, bring it inside, but then I'm going to take this 3 and bring it out front. So 3 times 3 is 9 natural log of x minus 1. Right, so typical problem you might see on a test. Well, we've expanded this thing completely out, and now, folks, it's time to take the derivative. So the derivative of x is 1, so this becomes 3 over x, plus, and the derivative of x plus 1 is 1, so this is going to become 6 over x plus 1, and then this next one over here is going to be, I shouldn't have wrote a plus there, I should have wrote a minus. Okay, so let's write a minus, and then this is going to become 9 over x minus 1. So you see, it's real easy to take the derivative as long as we expand this thing all the way out. Alright, and I believe that that's going to end on the natural logs, and I think we're going to move right on over into the log functions now. We're working natural log functions, and now we're going to move right on into log functions. And no rhyme or reason, I'm just going to say f of x instead of y. Doesn't matter. Bottom line is we take the derivative of this correctly. Okay, so just like the natural log functions, this time there's just been one little thing that's been added to it, and that is this still stays the same. We take the derivative of what's in parentheses, and the derivative of x is 1, and then we rewrite x, but this time I'm going to write the natural log of the base of log here, and the base of log is 10. Now we don't write 10, 10 would be written right here, but we don't write it here. If it's a 10, we don't write it, okay? But it's assumed to be a 10 right here, and this is log base 10. So we put the 10 right here, and guess what? We are done. That is the derivative. Yes, it is, folks. Alright, let's look at another example. Man, this is getting funner by the minute. What happens if I had y? We're going to use y this time. Like I said, it doesn't matter. Y is equal to log of x squared plus 1. So we are asked to find y prime. So we take the derivative of what's in parentheses, which is 2x. We rewrite what's in parentheses, and of course I'm going to write that in parentheses, times Now remember, there's a 10 here, even though it's not written. The natural log of 10. Okay? Alright, let's write one. Let's do one with the base is different. The base is going to be different. Like, let's say, alright, let's look at this notation. Right, so we're just using different notation, no big deal. This way, if you were asked something like this, you'll know what to do. Alright, this time the base is 5. But that's okay. We take the derivative of x, which is 1, and we rewrite x, right? Rewrite what's in parentheses, and this time we say the natural log of 5. So you see, whatever this is right here, we just write it right here, the natural log of it. Okay, so that's the derivative. What if we had d over dx, right, asking us to take the derivative of log. This time we'll say we have a base of 7, and it's x squared plus 1. Okay, so we take the derivative of what's in parentheses, and the derivative of x squared is 2x, and of course the derivative of 1 is 0. And then we're going to just rewrite times, and then natural log of 7. Natural log of 7. Good enough. Let's see, we got d over dx, and this time we're going to have the log of x minus 1 over x plus 1. So guess what? We're going to have to expand this thing first. Okay, we want to expand it. So in other words, I'm going to go ahead and write this notation here. This is going to be log of x minus 1 minus, because it's divided by, however you want to say that. Right. Now we take the derivative. So this becomes 1 over x minus 1 times the natural log of 10 minus 1 over x plus 1 times the natural log of 10. Right. So that's going to end up being the derivative finally. So we have to rewrite, expand it out, and then take the derivative. All right.